All right, so hello and welcome. Here we go. Let me see, take a moment to make sure everything's working. Figure I'd come back and do a few things. Let's see, a few things. Okay, very good. So we're live. Pop the chat out, the audio's working. All right. So, what is this? Oh, there's heart emojis? Okay, interesting. Okay. Sure. All right, so just wanted to say hello. Come on here. I think I can kind of get right into things. There's a few things I want to say before I begin. First things first, I have not been on for some time because what? Oh, I see. Haven't been on for some time because I have a lot of work to do personally, kind of figuring things out in my personal life. I have like a whole page full of just notes of, not notes, actually, it's each line is like another item I need to do. I've still got like half a page worth of things I got to do. So yeah, here we are. I have less than 1,000 medium questions left. Seems like they keep adding more questions as I do more questions, so I'm always like slightly behind. Not behind, but I'm always like there's more distance to go. But I think if I just do all the mediums, then that'll be the bulk of the work, and then I can switch to some hards, then go back to some easies, and then go back to hards, just kind of jockey back and forth between the two. I've solved over a few different, just FYI, those who are curious, over a few different websites. I've solved maybe a couple thousand questions by now, about 800 plus here, about 600 plus another website, and then I think HackerRank I have probably around like 3 or 4 or 500, and then there's two other websites. On Project Euler I did like 150, and on another website called Foreclosure I did another 150. So it's like 300 plus like this is like 870 plus 630 is like that's 1,500. Yeah, it's like 300 plus 1,500 plus another probably like 400 on HackerRank. So it's way over 2,200. But anyway, just so people are aware of that, because I see videos online every now and then of people like I don't know, I get kind of envious because I see people that post videos of like, oh yeah, here's my advice to you to HackerRank, and they've got like there's 1,700 problems solved on LeetCode, or yeah, and I'm like, I probably have solved more than that person. And I'm like, yeah, I have. Like, just so people don't get the wrong idea. It's like I've been doing a lot of these questions, or maybe for myself, not even for other people. Just remind myself. Anyway, that's pretty self-indulgent. The things I want to talk about are I have yes, there's a lot of like, so I am like I'm not really politically active, but I have views that are very unusual, we'll say. Views regarding like racism and Jews and all kinds of other things, non-whites. And basically, yeah, Israel was attacked, according to the news, what the news says. And it looks like they're going to basically exterminate the Palestinians. Who knows what that means for the future for everybody. So that's been kind of on my mind. I kind of had a hard time actually sleeping because not just because of that, because of like a lot of other things on my mind. But yeah, I don't know what to say. Quite frankly, I don't really know. There's a lot of stuff you could talk about, a lot, especially just Jews in general. You could talk about them. You could spend a lifetime studying these people. They're very interesting people. But yeah, I don't know how much of that also is like safe for YouTube kind of thing as well. Jews control YouTube; they own YouTube in some sense. So I don't necessarily know, what I might come against if I sort of speak out of line, as you might say. So yeah, for that reason too, I'm also going to be a little bit less inclined to share my thoughts on some of these things. But it's a pretty big event in the world, and for those people who wonder like, why do you pay attention to Jews at all? It's like, well, right now we're in a position where the United States might literally go through World War III, and right in the middle of it are Jews. Almost literally in the middle of it. Like if you look at them geographically in the map, Israel's like it's like right in the middle. But anyway, yeah, it's a lot to talk about, think about with regard to those things. But I also there's like other things, yeah, I've been thinking about that are just unrelated. Like I was thinking I might want to get a PhD, might want to get a master's degree. There are jobs. I have an interview, I'm going to talk to a recruiter tomorrow. Maybe I shouldn't say which companies, but there's a company tomorrow that I'm going to talk to, and then on Monday there's another team member from another company that I'm going to talk to. And there's some I did put some stuff out on LinkedIn to try to find employment. And some people have been kind of checking that out and responding. Actually, somebody really interesting, they sent me an invite to this thing where you upload your resume, which I'm not really a fan of, like giving away personal information, but like you need a job, you know. It's like, what are you gonna do? You gotta try. And you kind of have to make certain concessions when like your livelihood is on the line. Sometimes, it depends. You kind of have to figure out for yourself how much you're comfortable with sacrificing, I guess. But anyway, yeah. So there was this company that someone reached out to me on LinkedIn. They were like, "Oh yeah, you can upload your resume, and they have a program that will basically try to find jobs for you based off your resume." I thought that was actually really cool. I mean, I know, like there's probably some like when you read between the lines kind of a thing, like there's always, there's nothing in this world is free, phrase it that way, right? I'm sure there's something in there that's like, I'm going to find out later, like, oh, that's what they were going for. Okay. That's what that was, what they were doing. But maybe it is just like, I don't know. They're just, for now I can kind of take it at face value, I suppose. And yeah, it was cool. It just gave me this like endless list of jobs that it's just like a few clicks to apply, and it gave me like what their program thought would be a good score, like how much of a match I would be for those jobs. And I was kind of flattered, like I often kind of grade myself pretty low on the bar as far as like how my skills and whatnot, and like what I could reasonably get. And quite a few of those roles that they said that I would reasonably, fair match or good match, were like senior software roles and staff engineer, staff software roles, and I think I saw one or two that was like a lead role, and I was kind of like, oh, okay, that's encouraging, that's positive. And yeah, staff software engineer is like it's up there as far as I know. It's like way up there. Yeah, and I had interviewed with Google in the past, and I've said a lot of things about Google in the past too. But job's a job, man. I'll work if unless it's like really obviously not a good thing that I'm working on. I'll almost work for anybody. And yeah, I don't know. There's the recruiter I reached out to at Google. The recruiter I had conversations with, the recruiter that I had conversations with at Google years ago, a lot of stuff happened. We kind of put those plans on hold, and I never got back to them. And then very recently, actually, they left Google. The recruiter, actually, it was a whole group of recruiters that I was working with. All of them had left, sort of all at the same time. Well, not all at the same time, but all recently. And there's one that might still be there that I could reach out to. I haven't tried that person yet, but I tried some other people to see what their thoughts were. But I don't know. I guess I didn't get an email back from them, so I don't know. It may just be because it's kind of almost like cold calling, like because you're emailing that person's team, but you were never introduced to their team, then they're going to be like, I don't know who this person is. Excuse me. So I don't know. We'll see. We'll see about that. But yeah, so that's like that's one of the companies. I think it's okay for me to share that. That's one of the companies that I'm interested in, because I don't know. I kind of would prefer not to share too many details about the companies I interview with and whatnot. But I think that one's fine. That's probably okay. Anyway, yeah, and like think about some other stuff too. Like I was looking at some cybersecurity related things. Like I'm pretty sure I can do integer prime factorization using like a heuristic algorithm that has a reasonably high chance of success. In other words, it doesn't always factorize the integer, but it has a reasonably high chance of factorizing integers efficiently. Meaning, like very large integers could be factorized with this algorithm quickly, right? And the implications of that is that it's not necessarily a phenomenal like a phenomenal thing, because it's not a correct algorithm, like it doesn't always work, kind of a thing. But it might work, and why that's meaningful and possibly really a big deal is that RSA allegedly is connected to, I think it's Diffie-Hellman and RSA, something like that. There's basically cybersecurity related like algorithms, significant ones that are in use rely on the fact that, now that's the thing I get confused about. That's actually something I've been thinking about and kind of getting stuck on, is that apparently they rely on the fact that the discrete logarithm is difficult to compute, which is not the same thing as integer prime factorization. However, at the same time, allegedly, if you can do integer prime factorization efficiently, then you also can do something like the discrete logarithm efficiently. And I kind of was thinking about it. I was like, I don't really fully understand that connection there, because I don't think it translates I don't think it translates that easily. Like I don't think it's that obvious that you can use, an algorithm that could factorize find the prime integer prime factorization efficiently, and then immediately if you could do that, immediately translate that to basically breaking encryption on the internet, right? That's kind of what I'm getting at with this, is that I may have found something that could break a lot of the encryption on the internet. But one, I don't know if the connection is really that like direct. It's if it actually can work that way. It's not obvious to me. I have to like study it for a while to see like how it actually would yield that result. And the second thing is the algorithm that I have at present. I'm working on one that will always work. Sort of in my mind, I've been thinking about it, but I did find one that probably works a lot of the time, which is like, that's enough to break into stuff. Quite frankly, like if I wanted to start busting open encrypted messages on the internet, that's start doing some really I think those things would be illegal, probably, the things you could do, but in theory you could do it. Is what I mean. Not so much that you should do it or could, or not that you should do it, or would do it, but that it could be done. Yeah, and I think the amount of computing resources that have been committed to projects that are comparable to that, it's like a ton of money people dumped into like all kinds of cybersecurity related things to kind of break various encryption schemes. And I thought about it, and I was like, here I am basically with like almost no money at all. I'm like about to best these people that have, some of these programs that spent billions of dollars, and it's like, I don't know, man, like, yeah, it kept me up. Like, it was one of the things that it was hard for me to sleep, because it's like I've often say like I have a tremendous amount of power, and it's hard for me to even like fully comprehend it. It's hard for me sometimes when I think about it. It's just like, dang. Dang. That's all I can say is like, wow, that's okay. Here they spent billions of dollars on this. Here you figured this out on your own in a few years, and without really any much money at all, just on your own. It's like, that's pretty good. It's impressive. But yeah, but that's the thing, is like, I don't know if it's not totally there. I'm definitely there for something that probably works, that can do integer prime factorization. That much I'm like certain of. But whether or not it translates that easily to breaking encryption, and how often it works, and all those sorts of questions, and if there's an algorithm that's exact, in other words, it's not It's not like there's a probability that it might fail. Like it just will always work. That's a little bit harder of a thing. And I also thought about this question too, because I stopped on this question the other day, and I kind of was like, I thought about this one. I think I have the answer. The idea I'm going to go for, and I mentioned it too before the stream ended. What I would go for is, well, okay, let's just go just look at the question. I'll explain it. Explain what the answer I'm going to go for. So, also let me just see. Did I have the chat out? I think I do. Yeah, there we go. Okay. Distribute coins in binary tree. You're given the root of a binary tree with n nodes where each node in the tree has node.val coins. There are n coins in total throughout the whole tree. In one move, we may choose two adjacent nodes and move one coin from one node to another. A move may be from parent to child or from child to parent. Return the minimum number of moves required to make every node have exactly one coin. Okay. So I think the way to do this, I was pondering this. I think the best way to do it is, let me give some examples. You have 3 coins, you can push one here, one here. You have 3 coins here, you push one here, one here. Right, and that's 3 moves here, and this is 2 moves here. And it gets kind of complicated, or can get more complicated, the maneuvers. But I think you could do this recursively using a depth first search, and you basically just say, look, count the number of nodes in the left subtree, and the number of coins in the left subtree. Count the number of nodes in the right subtree and the number of coins in the right subtree. And what we're going to do is whatever the difference is between these two, right? Well, actually, not even that. You could take the sum of the left subtree nodes, the sum of the right subtree nodes, plus one more node, plus the coins here. So you get the sum of all the coins, sum of all the nodes, and you have some results that you're going to be keeping track of. And you're going to increment the result by the difference between the number of coins in the subtree and the number of nodes in the subtree. And I'll explain in a moment why you'd want to do that. The absolute value of the difference between the two. And then you're going to return the number of coins as a return value and the number of nodes as a return value for the subtree. So obviously the first node all the coins and all the sub nodes should be equal. So you should just get 0 for the first node. But when you iterate on the left side and the right side, what should happen is basically whatever the difference in coins is for this subtree, either that's how many coins need to come out of this subtree and go into the other one, the other subtree, or that's how many coins need to come from the other subtree and into that subtree, right? And what's interesting about it is I was trying to figure out exactly how this should be understood. I couldn't, I don't know, I was having a hard time in my mind envisioning it. Also, I had so many other thoughts like kind of clouding my mind. My thinking is that, like, if you have, let's say you're like here, you're missing a coin here and you're missing a coin there, right? One node, 0 coins, you're gonna have to move a coin here into, right? The same thing over here, you gotta move a coin into. What's weird about it, peculiar about it, interesting about it, is that you don't really need to think too hard about, like, to move a coin from here to here, you got to go up and over, right? And same thing in the other direction, up and over, right? However, this is kind of handled by those two sums inherently, because if you have an excess of coins, you're going to add the number of coins you're going to push up. And if you have a deficit of coins, you're gonna calculate how many had to be pushed down. And so between these two sums, you already get, for every individual coin, you get the 2 parts that you need. And so it's a little weird, because at first you're like, wait, does that work? And the answer is yes, but it's not so obvious that it works this way. And this will be a linear time, by the way. This will be a linear time solution. But yeah, it's kind of a peculiarity, quite frankly. It's a little bit weird that it works this way, but basically it's like a post-order traversal. And I think this is fine, and I think it's actually pretty quick to program. And yeah, we'll do it this way. So we have some return values. We have int. We're going to say coins, and we'll say our coins, return coins, or coin count as a reference, coins, and then also as a reference of the nodes. Right, and we're going to call it DFS, and this should be very quick to program, quite frankly. A few things. DFS, we're going to say int coins nodes, start them off at 0. And root. So I think it's something like the following. If not root, then you just return, you set coins equal to 0, set nodes equal to 0, and return. Right, no return values to be considered. And you actually could do two different, you can modify the return values like this. It doesn't have to be this way exactly. There's different ways of doing this. This works too. I kind of would prefer to have 2 return values, but this is fine too. So we'd have int left coins, right coins, constant left nodes is going to be root left with coins or L coins, and then the other side. It might be better to do. It might actually, yeah. Well, okay, we'll just skip this one. It's fine. Right nodes is going to be on the right side with the right coins, right? And what we're going to return here is going to be the number of nodes, which is going to be the left nodes plus the right nodes plus 1. And we're also going to return the coins are going to be the left coins plus the right coins plus root value, number of coins of the root. So we're returning both the number of coins as well as the number of nodes, and we'll say nodes. And we're also going to return or update this result value with the absolute value of the difference between the coins and the nodes. Doesn't matter which one we take, this one or this one. Yeah, something like that. Thinking, is there anything else I should say? Yeah, just return 0 nodes and coins for the left and right. What do they call it? Empty, or the empty, the empty nodes, what do they call that? The nodes that are, this should be linear time, by the way, in the number of nodes. Let's do just a whole bunch of 1s. I forgot what I was even saying. Empty. I don't even remember now. For the, what's that called? What are they called? Empty nodes? They're the nodes that are not leaves. The null nodes, that's what it is. Yeah, null, children that are null. Yeah, the null children. Or the missing children, or the absent children. Yeah, absent children should just return 0 coins and return 0 nodes. And that should work out fine. Yeah, and apparently this works. Like, it's pretty straightforward kind of thing. It's pretty cool. I don't know what else to say about it other than I'm kind of proud I was able to figure this out, I suppose. Does this one still, does test case work? And then we'll just start removing some nodes just to see. Okay, very good. Nice. Have some null nodes here and there. Let's remove some things. We removed 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we want 1, 3, 5, 6, 10, 11, 12. Hopefully that still works. Just kind of mess up the structure of the tree a little bit to see everything sort of works as it should. Yeah, okay. Do this one too. Just add some null nodes. And another null node over here. All right. Then I guess I'll go for just a single node as well. Exactly endpoints. Oops. 1, 2, 3, 4, 5, 6, 7. 1, 4, 5, 6. 7. I think I deleted too many. I don't know, or what I did exactly. To do it right. Whatever I did, it wasn't correct. All right. This kind of seems reasonable. I don't know what else to do here. So just have 1 coin, and let's say we have 1, 2, 0 or something. 2, 0 and 0, 2. I think this is it, by the way. I think I got it. I just want to be a little careful, 2, 0, 2, null 0. Was that what I had? Just 2, 0 was, yeah, okay. Let's do another 2. 1, 2, 3, 4, yeah. Okay, let's see how that goes. All right, I think that's it. I'm gonna go for it. Feels like it should be correct. I could be wrong. It could be something important that I'm missing. But I don't think so. Oh, there, I got it. Sweet. Hey, very good. Very straightforward, actually, solution. Like, very straightforward. Wonderful. I really got stuck. I kind of got hung up on this before when I was thinking about it. Yeah, it's not too bad. That's very clean. All right, I'm gonna submit it 5 times, and we'll go on to the next question. What I'm gonna do is I'm gonna submit it 4 more times, and then I'm gonna try to get 0 milliseconds. There's only 100 nodes, so it should be excuse me. It should be pretty fast. It should be really fast, actually. I'm a little bit surprised that it's running so slowly. I guess technically you could do this with maybe you could do this iteratively and it'll be faster, like with a stack or something instead of DFS, but I'm not really sure. Kind of don't know why it's running so slow. Quite frankly, it should be like just 0 milliseconds every time. But I could ponder that for a while, why it's so slow. I think it's got to do with there's just a bunch of things going on here. Like it's a stack, it's recursive, it's using it's going through all of the, it's doing an extra kind of layer of work because of the children, processing all of those empty children, and it's also the memory is not contiguous memory because it's a what do they call that? It's not contiguous memory because it's a binary tree. Excuse me, it's using pointers to the children. So yeah, it could be all those things. I don't really know what to say about it, but this is very clean, very straightforward. Let's go ahead, and I was supposed to do this. I kind of did this wrong. So yeah, I was thinking about this also when I was going to sleep, that question, and I came up with that solution, and I think that's a pretty good solution. It's kind of hard to be absolutely certain that it's correct and do it really quickly and submit it quickly. Quite frankly, that was kind of a little bit challenging, but other than that, once you know it's right, coding that is very, very quick. That's a neat question. That's a good one. All right, so what I want to do is stop the stream. Hail victory. Hail victory. And stop the stream and then start it again with the next question. So I'll do that now. So I'll be back in a minute or two. Thank you for watching. If you like the stream, don't forget to like the video and follow, subscribe.